Assalamualaikum warahmatullahi wabarakatuh and hi everyone. Okay, let's continue our lecture in subtopic 3.1 roots of nonlinear equation under bisection method. Okay, you have to remember our aim here we use bisection method to find the solution of x, or we want to find the root of solution fx. Okay, bisection method is a bracketing method which search a root of fx using two initial guesses. Okay, we involve determining the estimated root of ci equal to ai plus bi over 2. Okay, by using this iteration, the size of interval will decrease until it leaves the value of fci converge to 0 at a point ci. Okay, next, let's move to steps to solve using bisection method. Okay, first you need to identify a naught and b naught from the equation. Okay, if a naught and b naught are not given, you need to use intermediate value theorem to find the initial guess. Okay, next is you need to calculate the first estimate of the root ci using ci equal to ai plus bi divided by 2. Okay, for example, let's say you have ai and bi here. So you need to find the middle point between ai and bi. So you use this formula ci equal to ai plus bi divided by 2. You get ci here. Okay, next you need to determine whether the solution exists between A1 and C1 or B1 and C1. Okay, let's say you substitute F A in Fx, you will get FAI. When you substitute CI, you will get FCI. And if you substitute BI in Fx, you will get FBI. Okay, let's say we have FAI is negative, CI is positive, and BI is positive. So we need to choose the point with different signs. So here A and C have different signs. So we choose interval AI and CI for next iteration. Okay, repeat the same step to find the middle point between AI and CI. AI plus CI divided by 2. Okay, so you need to proceed the iteration until you get F CI equal to 0, or B the epsilon is given based on the equation where epsilon is an error tolerance. Therefore, an approximate solution is the CI. Okay, we will look at the example on the next slide. Okay, let's see example 1. Find the solution of exponent negative x minus x equal to 0 in the interval between 0 and 1 by using bisection method. Okay, use 3 decimal places in all calculation. So the equation gives you fx equal to exponent power of negative x minus x equal to 0. So I suggest you to construct a table. So for the first column is the iteration I. The second column is AI. Next BI. Next column is CI, which is AI plus BI over 2. Next is FAI, FBI, FCI. Okay, for the last column, okay, you need to choose FAI, FCI less than 0 or FBI, FCI less than 0. Okay, so first you need to start the iteration with 0. Okay, always start with 0. So AI here is 0, BI is 1. So to find CI, AI plus BI over 2, so 0 plus 1 divided by 2, you will get 0.5. Okay, for FAI, you substitute AI equal to 0 in Fx, you will get 0.5. For you will get 1. Okay, for FBI, you will get negative 0.632, and for FCI, you will get 0.107. Okay, for this column, okay, you need to choose FAI times FCI or FBI times FCI. Okay, you must remember it needs two different sign here. So you can see here AI, BI, and CI. So AI is positive, C is positive, and BI is negative. So you need to choose between FAI, FCI, or FBI or FCI. So here I choose FBI, FCI less than 0. The next iteration 1. So AI here become 0.5 because I choose FBI and FCI before. So BI is 1. So CI is 1 plus 0.5 divided by 2, you will get 0.750. For FAI, you will get 0.107. For FBI, you will get 0.632. For FCI, 0.278. Okay, now I choose F, A, F, C less than 0. So for the second iteration, A here is in 0.5. For BI become 0.75. Here A is 0.5. For C is 0.75. So same to find CI, 0.5 plus 0.75 divided by 2, you will get 0.625. For FAI, 0.107. FBI is 0.278. FCI is negative 0.090. Okay, here also I choose FAI, FCI less than 0. So you can proceed the iteration until FC is equal to 0. Okay, then stop the iteration. So the C will be the root. When the iteration FC is 0, so C is will become the root. So you can write here the root of Fx is approximately 0.567. For example 2, find the root of x power of 4 minus x minus 10 equal to 0, accurate to epsilon equal to 0.015 in interval 1.5 and 2 by using bisection method. Okay, use 3 decimal places in all calculation. Okay, now you are given value of epsilon. So this epsilon is called stopping value. Okay, you need to stop the iteration when the value of epsilon is equal to 0.015. Okay, first, as usual, you construct a table. So for first is iteration AI, BI, CI, FAI, FBI, FCI, and the last column is AI minus CI smaller than or equal to epsilon, or BI minus CI is smaller than or equal to epsilon. Okay, let's start with 0 iteration. So AI here is 1.5 and BI here is 2. Okay, for CI as usual, you need to plus AI plus BI divide by 2, you will get 1.75. Okay, for FAI, FBI and FCI, you substitute value of AI, BI and CI in this fx. So you will get FA equal to negative 6.438, FB equal to 4, and FC is equal to negative 2.371. Okay, you can see in the last column, you get epsilon 0.25. Okay, this is not 0.015. So you need to continue the iteration. Okay, to choose AI or BI, you need to look the sign. Okay, based on intermediate value theorem, you need to have different sign. So first we look at FA and FC. Okay, you cannot choose FA, FC because we have same sign. So you look at FB. So FB have positive and FC is negative sign. So you can choose for the iteration 1. Okay, AI is 1.75, which is C here. So B is remain the same. So since that substitute A, B, C in fx, you will get this value, and for the value of epsilon you get 0.125. Okay, still we don't get epsilon equal to 0.05, so you need continue the iteration. So for iteration number 2, okay, we choose A sim 1.75, and for B here we choose 1.875. Okay, because we FA have negative sign and FC is positive sign. Okay, so for the epsilon we get 0.062. So we need to continue the iteration. For iteration number 3, okay, for AI we choose CI is negative, and for FBI is positive. So for AI here is 1.813 and for BI is 1.875. Okay, we look at the epsilon. Okay, we get 0.031, not 0.015. So you need to continue the iteration. And the iteration number 4, you get epsilon 0.05. So here you can stop the iteration. So CI here is the answer. So this is the answer. Okay, I think that's all for this video. Okay, I will continue the next video with the other method. So thank you.